Hi, everyone. I'm Beth Johnson, and with me is Dr. Franck Marchis. We're here to take a look at some of the science coming up this year that we're all really excited about. On the menu is Mars, of course, the moon, a few asteroids, a helping of Venus and Mercury with a little bit of James Webb Telescope, and potentially even a first light for the Vera Rubin Observatory. And for dessert, we have the possibility of SETI discoveries. Hi, Franck. How are you doing?
I'm good. How are you, Beth?
Pretty good. Busy week. We're all kind of doing
Week
the
two.
AAS conference thing, and
Yeah, it's a lot happening right now.
there's a lot happening right now. But there's a lot coming up this year, too. So why don't we kick it off with looking at these Mars missions that are coming in for a landing, basically?
Yes, so we have three main missions arriving in February, April. Let me just talk about the elephant in the room here, the Perseverance mission, the NASA mission. That's a big rover here. We're talking about $2 billion mission with a partnership from other countries, including Spain, Norway, and France, and led by NASA, JPL, to be more accurate. So the goal of this large rover is to explore the Jezero crater.
And
Um,
what's special about Jezero Crater? Why are
it's
we there?
we'd go there because we think that there was some kind of water and maybe some kind of activity as well, um, geyser-like activity from the structure that they saw using a spacecraft from above. So the idea is to go over there, analyze the rocks. So the robot is basically a geologist, a very expensive one, who's gonna take rocks, analyze them using. There is a lot of instruments, but one of the most interesting one for me is the Raman spectrometer. I forgot the name of it. A Sherlock. It's
Oh,
been
right, Sherlock. And
yeah.
there's also a Watson that does something else.
So
Eh,
the Sherlock is a Raman spectrometer. So Raman spectroscopy is basically you illuminate with a laser and you look at with a magnetic field as well, and you can see organic material. And that's very interesting because the goal here is truly to find some indication of the presence of life in the past of Mars. It's the
Right.
first
So
time.
this is different from the previous Mars missions in this respect. So here we're really literally looking for signs of past or even present life, small as it will likely be. But the previous missions hinted that there might be the possibility that there were conditions that could be right. But now we're really setting out to see if we can find it.
Yeah. So find it, put it in a cache, gather it in one place like a squirrel will do, basically preparing for the winter, and then hoping that we get funding in mid 2020 to send another spacecraft over there who will this time grab the samples and bring to us. So it's a
So that
very ambitious program.
so
So
the goal is a sample return, but in several years.
exactly.
Okay.
But there is some cool stuff with the rover that I think we should mention.
Okay.
One, there is an helicopter on it called
Yes.
Ingenuity. It's a tiny kind of helicopter. It's going to be able to fly around the rover and inspect the terrains and see the topology in advance. You've seen probably how slow has been the rover Curiosity because it basically moved by a few meters every week because they're
Right.
extremely careful because they don't want to have the thing stuck in sand dune, for instance. So this will basically accelerate the exploration because this helicopter will be able to fly around and inspect the terrain very quickly, giving a better idea of what is more interesting to see in this area.
Right, but it's a test flight really, and it
Yeah.
doesn't have any science instruments of its own. So it's there to sort of look around and figure out, can we actually fly a drone helicopter on another planet with a very thin atmosphere?
And then I like that there is the instrument called MOXIE, which stands for Mars Oxygen through Experiment. It's an instrument that will test if it's possible to generate oxygen um, for the future exploration of Mars, for human exploration of Mars. So
And how is it going to do that?
it's gonna take samples and do some kind of magic that I don't know about because I'm not a chemist and I really don't like chemistry. So don't ask me too much detail about this. And generate by those process some oxygen molecule of oxygen, and it's a test. Basically, it's a test instrument to see if it's possible. Theoretically possible, but it depends, of course, the type of rocks we have on Mars. So that's why they have to bring an instrument on this rover to do this kind of test. And there is one more thing. There is two things very cool, but one very cool that I hope this time's gonna work because in 2008, when Phoenix landed, it's one of these missions that landed on the pole. One instrument did not work was the microphone. And the microphone was supposed to record the sound of Mars. So this time, there is again a microphone on this rover. So I'm hoping that with this rover, we'll be able to hear Mars, to hear what the surface of Mars, the wind, the cracks of the rocks. I don't know what we're gonna hear, in fact, but it's gonna be very interesting to be able to.
Well, that's exciting. I missed that one when I was looking everything over. Thank you. What's the other one? You said there were two.
And then Sherlock is gonna be used to analyze. So they are really thinking about exploration of Mars by human. And as you know, human cannot live on the surface of Mars. They need to bring oxygen. So MOXIE is the experiment to create oxygen from the rock. But they need also to live into this kind of, how you call this, outfit combination, astronaut outfit, basically. So they have samples of them on the spacecraft. And Sherlock is going to analyze them regularly to see the degradation of those samples, to be able to see what will be the best material to use to be able to for humans to build those outfits to explore Mars in the future.
So Perseverance is carrying basically fabric or material samples for astronaut suits, essentially.
Exactly.
Okay.
There is a lot of stuff like this. I mean, I got lost this morning reading a lot about this, and there is some very cool thing on this mission, more than just a mission to explore the Jezero crater.
That is, we don't hear enough about some of the smaller projects on there. Those are really cool. Thank you. So I know we have two other missions arriving at Mars. One is Hope, which is the first Mars mission for the United Arab Emirates.
Yeah.
It is an orbiter. It's supposed to be the first one of these three to arrive. So I'm looking forward to this. This is going to be a big deal for them if they get that all inserted into Mars's orbit properly. Is there anything exciting about that one, special about that one we should know about?
Yeah, it's gonna join basically this constellation of spacecraft we have around Mars already. It's equipped with instruments which are very classical, an imager and spectrometer in infrared and the spectrometer in UV. What's very important here is that a small nation, like a new nation like the Emirates United, is basically designing and operating a spacecraft. And, I think it's great. It's great there is more people, more countries now capable of developing technology, space technology to explore planets.
Absolutely. And, space is hard. So it's always great when someone else kind of joins the fray, so to speak. And then we have
the last one.
Yeah, we have the third one is a lander. So we have China is going to try and land on Mars. They have the Tianwen-1 Mars lander that should be arriving in between Hope and Perseverance. Now, it's not going to land when it gets there. It's going to do some orbiting first and get prepared to do its landing. And I think the scheduled landing is
April 23rd.
Okay, April.
I look.
Okay. I knew it was a little bit further out, like a couple months away. So it's going to go and it's going to orbit for a bit, get all prepped, and then they're going to try and make their landing later on in the year.
So they're going to land in an area called Utopia Planitia, which is the same place than the Viking 2 lander landed in 1976. So one of the reasons they are interested in this area is because they expect to find a lot of water. We think that this is a water reservoir. So with this lander and the rover as well, they will be able to inspect the surface and detect the presence of this water. There's a
Okay.
significant difference here is that the rover is a very small instrument. Okay, we're not talking about a gigantic nuclear power.
No, this is not Perseverance
Yeah,
Curiosity sized. This is
this is
more
more like
Spirit Opportunity sized.
exactly, exactly. It's supposed to stay alive for 90 days on the surface of Mars. But last time with Spirit and Opportunity, we had to wait for, I don't know, many years, more than 3 years.
Opportunity lasted like more than a decade, I think.
Those things never die, right?
And when it did, we were all so heartbroken.
Yeah.
The
So
the
you will
internet
have
was full of memes.
the rover will have this ground penetrating radar to be able to map the underneath the surface and see if there is this kind of water reservoir.
Okay.
So
And this last year, actually, we there was a lot of news about subsurface water reservoirs on Mars. So this may help confirm what we think is going on with those. This might be able to tell us that yes, no, really, those are there. Right? That's what we're looking for.
exactly.
Okay.
And there is then the technological challenge. I mean, there is no many nation which landed on Mars. United States did it like 8 times now.
Hmm.
Europe never managed to do it. Um, Russia did it for with one mission that lasted for a few minutes. I forgot which the name of this mission. So if China managed to land Tianwen-1 lander and operate a rover, they will be really truly into the top three
Right.
nations.
It's a huge step forward for their space exploration program.
Okay.
Okay, so that's Mars. Everybody was, that, like you said, that was the elephant in the room. But Mars isn't the only place we're landing on this year. We're also looking at the moon again,
Yeah.
and people have started going back to the moon. So we had lunar landings in the last few years. China has did a return mission with a sample just at the end of last year. What have we got going on this year?
So in the US, there will be again the big mission is Artemis One. So Artemis is a new name for the program, for the equivalent of Apollo, but for the year 2020. So Artemis One is the first mission. It will basically consist. It's an uncrewed mission, and it will be basically a flyby of the moon. What is very important here is that Artemis 1 is supposed to be launched at the end of the year by the new rocket called SLS, the Space Launch System, which is a rocket designed specifically for this kind of program.
Which we've been waiting on for a while.
Yeah, you're very polite when you say a while. For way too long, I will say. But anyway.
Yeah, let's go with that.
um, Artemis 1 will have a lot of small missions because it's such a big rocket. We can put the payload is you can put a lot of small satellites in it. So there will be one of them is called the Lunar Flashlight. I remember we talked about this because in the past in one of our city life, it's gonna basically be a space satellite capable of imaging the pole of a CubeSat capable of imaging the pole of the moon to better understand if there is some water there and search for the composition of this water specifically, if it's water ice. Yeah.
Right. So we're pretty sure it's water ice now, but there's still that possibility that we're looking at some sort of hydroxyl, and we need to know before we send people.
Exactly, because they will need to be able to drink something, right?
Right.
And then there is two commercial missions. I don't know if you know about those.
Reminds me because I
There
was
is
looking at
one called the
non-commercial stuff.
Peregrine Mission One, and there will be this kind of tiny rover that will walk on four legs. It's a
Oh,
very
I have heard about that one. That one looked
yeah.
really cool.
This is supposed to be launched by Titan rocket, one of the new Titan rocket. And then there is Intuitive Machine Lunar Mission 1. They need to find better name for that. And this one will be launched by Falcon 9. And there will be a lander and an orbiter. The lander is called Nova C. And that's a private mission as well. So it's great to see an interest of private industry for the moon. And now they are testing the capability they developed over the past 3 to 5 years. So we may have a first private missions on the moon soon.
Okay.
You can ask me why space mission, why private industry is interesting in the moon, right?
Right.
Well, because that may be the new place we're gonna establish a base and human gonna settle. So
Right. We're sort of, I know a lot of stuff is trying to prep for the whole gateway project that people are getting into.
so there is Capstone also. I don't know if you know about this one. It's a tiny satellite. It's a 12U, and it's gonna be placed in the same orbit than the Gateway, the famous new space mission. We're having this very eccentric orbit around the moon. So sometimes very close to us, sometimes very far to us, and very close to the moon and far to the moon as well. And the reason NASA wants to place first satellites there is because they want to make sure they can operate the satellite properly, they can communicate with the satellite, because the goal is to send the human in this type of orbit in the next 5 years. 2024, I think, is the gateway.
Yeah, I think Artemis and the gateway are sort of planned for 2024. I'll keep my skepticism to myself.
Okay, so there is more things happening on the moon. In fact,
Right, but let me just take 1 second and thank some people really quickly for watching. We've got people watching from Salt Lake City, Utah, Canada, which that's a very Canada, all of Canada, I assume, Minneapolis, Minnesota, Chile, California, Vietnam, Japan, and Johannesburg. So thank you everybody for tuning in from all over the world. And also a special thank you to Susie Bailey, who sent 900 stars over on Facebook. Your donation is appreciated. So thank you. Okay, back to the moon. We're not the only ones playing around on the moon again.
yeah.
So who else is playing around on the moon?
So one surprise to me when I was looking what's going to happen is that Russia is going back to the moon. So you're probably too young, and I'm very young. The last time Russia sent a mission to the moon was in 1976. It was Luna 24.
Okay, I was alive. We'll leave it at that.
I was 3 years old. So now you know my age.
I was 1, so now you know mine.
So we have a new mission called Luna 26. And this Luna 25, sorry. This is Luna 25 is going to land nearby on a crater nearby the lunar South Pole.
Right.
I have the name. Bokuslavsky crater, to be accurate.
So now my understanding on this one is that there's not really any new technology involved. That Roscosmos is actually sort of trying to update their existing technology from the original Luna 24 mission. So they're actually using several decades old, you guys can do the math, technology to do this again, right? Is that's correct? Yeah.
That's what I heard too. I mean, I don't know much about it, but it's interesting that I kind of like the idea of them going back to the moon with the same technology, just to show that they can still do it with the rockets and so on. And then they will probably improve that renders in the next generation. I think they want to do something very quickly because India is going to the moon too, again.
Right. India is sending their 3rd lunar mission, Chandrayaan, to the moon. And this is another lander. What is this one there to do?
I don't know much about this one, and I frankly did not find much information except that it's going to be a smaller lander than Chandrayaan 2. The propulsion system is different as well. So there is a hope that this one will succeed because, as you know, Chandrayaan-2 did not succeed.
Yep. There
We
there were issues.
There was issues, yes. So that's a mission that's going to be a launch on the moon to explore the moon, to do some analysis of rocks, etc. The same kind of missions, the same kind of priority that we wanted for Chandrayaan-2. Um, I'm hoping this one's gonna land, definitely.
Right. So they had a lander and a rover for Chandrayaan-2 that crashed.
It was
Um,
2020 or 2019, I forgot.
2019.
2019.
2019. So this is their next attempt to go back and try things again. The orbiter is still in operation though.
Yeah.
And then I learned today when I was looking all of this up that the Japanese are apparently going to the moon now too. So they
Tell me
have.
about it, Beth, because this is something I didn't know.
I now I have to figure out. I have to find where I got the info from, but it was interesting. I had not heard of it, and it somehow escaped our attention, my attention on a different show I had done. Um, it's a lunar rover. It's a little tiny robot. It's named Yaoki, and it's gonna go on the commercial astrobiotic lander.
Okay.
So it's basically piggybacking on the Peregrine lander. So it's supposed to land in July, and I'm kind of excited about that. So this is also, I think this is the new ULA, United Launch Alliance Vulcan Centaur vehicle. And again, we're getting back into the private spacecraft. That's a private spacecraft, but we have this Japanese mission on it. There's a United Kingdom rover that's going to be on it too. So it's kind of an exciting event there. Not even a little event, a big event that hopefully we can get these new rovers in new countries out on the moon and have them exploring. So um, I don't know how I missed this in my initial pass through of all of this news, but I'm really excited I found it this time around.
Yeah, I think it's remarkable that we are the generation that's living this moment where private industry is basically designing spacecraft, rover, landers to explore the moon.
Mhm.
Um, that was kind of a dream in science fiction books that we are witnessing at the moment.
Yeah,
So,
and so the British one is the walking one you were talking about.
yeah,
So that's going to be on the same flight. So that's really exciting. There's lots of things going up there. I think that covers it for the moon, which is a lot. That was a lot. But now we're going to move out a little bit further, and we're going to look at asteroids. So finishing up sort of something that started last year, we sent JAXA, Japan's space group, sent Ryugu out, sent Hayabusa 2 to Ryugu, and their sample return came back in December of last year.
yeah,
So this year we get to find out maybe possibly what they learned from it, because they've cracked the canister and analysis is starting. And I know they've already done a little bit of analysis on the trace gases that were found in the canister. There's a paper that's come out that they're going to try and confirm what they found from in situ detectors about Ryugu not having a lot of water, far
mm,
less than they anticipated, and maybe the sample will help explain why that occurred. Was there an event that happened? Was it just solar heating? What caused this? My understanding is that because they discovered that because they so JAXA launched a projectile at Ryugu and blasted a small crater into it to get some of the subsurface regolith and not just the surface stuff. And they found from the measurements in space that that subsurface strata is also dry. So
yeah.
again, still far drier than we expect from asteroids, which of course we think brought a lot of water to Earth. And so they now think that that's a bigger event than just solar heating, which would have dried out the surface, but not necessarily lower down. So what else is there anything else going on with that? Did I cover Ryugu pretty well there?
You cover your group pretty well, except you did mention that there is also a lot of organics. When they
Right.
basically blew up the area, the make this artificial crater, they noticed that it was kind of darker than the surface. So this implied that there is a lot of organics inside the asteroids, and
So
that's
when we
very important for
but
us.
when
Go
we say organics, we're talking carbon-based molecules, not
Yeah.
necessarily
Yeah.
biological
No,
costs.
not biological.
No,
Sorry, I should have clarified.
it's okay. I just
So
know someone
they
will ask.
So yeah, we are. The analysis will be very interesting because we will finally know if there is truly organics coming from those asteroids and how much. We know that already because we have seen some of these meteorite, and they contain organics. And we will also, by analyzing the water, know if the water of Earth come from asteroids, comets, transsiberian objects, or something else, or a mix of this, because you can see the source of the water by measuring what we call the DH ratio. And that's something that you can do only in a lab after collecting a sample. That's one of the main reasons they want a sample of this asteroid.
Right, and it's not the only asteroid that was sampled last year. OSIRIS-REx went and sampled Bennu, but while that sample is stored and they're going to be sending the craft back to Earth, that won't get here until I think 2023. So we have a lot of time to wait on that one.
So I look
Um,
around a bit about how they're going to do the sampling analysis. So JAXA is gonna basically share the data with other institutions and other countries, especially 10% of the zero point 0.1 grams of material that they collected will be sent to NASA, specifically to the Goddard Center, because there is labs over there to do the analysis. And this sample will be analyzed, as I say, to detect the amount of of water, the type of water we have, the type of organics as well. So it's gonna be very interesting when this sample is gonna travel through the planet. I don't know how they're gonna do that, but I'm assuming they're not gonna use FedEx or
right, so they have an agreement with several different agencies
yeah,
that, and there's like percentages. Everybody gets a little chunk here and a little chunk there, and yeah,
like
I've
10% for NASA, 15% for international researcher, and 40% will be stored for future scientists. Because you know that we probably don't have all the technology yet to analyze those samples. So the idea is to store 40% of them, so the next generation of researcher or our future astronomers will be able to use the top instrument they have to analyze those samples and maybe detect things that we missed with our primitive technology.
our primitive technology. Okay, so moving on through the asteroids, one of the next missions we have is DART, which is kind of interesting. This is the double asteroid redirection test that is going to asteroid 65803 Didymos, and some of you might be familiar with it because it has a Diddy moon. And they want to basically shoot a projectile at it and see if they can alter its orbit.
That's correct.
What
So
do you
that's a
think about that?
planetary defense mission.
Right. It's a planetary defense mission to help save us from potential asteroid strikes later. What do you think of that? What do you think of this, the science going into this one? I think
Uh,
it's interesting.
I think it's great that we finally have a mission to test the technology that we think will work to divert an asteroid, which is kinetic impactor in this case. And we are going to test it on an asteroid to be able to quantify whether or not we do have the technology to do that. Uh, you have, we may discover in the next month or two that an asteroid will impact Earth in 100 years. We don't know. There is so many of them that
Right.
it's possible.
I mean,
Uh,
we think we found something like 95, 96% of the larger
yes,
asteroids in the asteroid belt. And but those are, I think, a kilometer and over. And anything under that, we're still working on filling those in. And if they're coming the other direction from the sun side, we don't see them very well.
exactly. So we want to be able to see them. That's the mission. We're going to talk about this telescope called LSST, or the Vera Rubin.
Mhm.
But this mission will test the mitigation, the way we can mitigate an asteroid, divert it slightly from its orbit. There is a component in it which is Italian. It's a CubeSat, and the CubeSat will be released before the impact and will take a picture of the impact. And also there is a European component called ERA that will come later on in 2 years, and will inspect again the asteroids to be able to see the impact crater and take some more accurate measurements of the orbit of the moon.
And so one of the questions that we've had in the chat is, why do we need to alter its orbit? And it's not so much that we need to alter Didymus's orbit, but we're going to see if we can alter its orbit, because if we can alter the orbit of one, then this potentially can work for altering the orbit of one that's actually threatening us.
Yeah.
And Didymus is far enough out that whatever we do to it won't have a big enough effect on its orbit to alter it enough to make it a problem.
And we don't expect to orbit to deflect the asteroid itself, but the moon.
Right.
It's the moon
Right.
that's going to be impacted.
So
it's safer.
Diddy Moon is a little tiny rock asteroid that is orbiting Didymus. So that's why we call it Diddy Moon. And everybody just thinks the name's cute. I like it. So it's going around. So that's the thing that we're actually altering. So we're not going to work on the big object. We're going to work on the smaller one. But that's not the only asteroid mission we have coming up.
Yes, so we have Lucy. It's going to be launched in November.
I'm excited for this one.
If everything goes right, yeah. Lucy has an amazing scientific goal, is to explore the Trojan asteroids population, the asteroids which are orbiting ahead and behind Jupiter in what we call the Lagrange points. This is a population of thousands of asteroids that we don't know much about. And that's one of my favorite population of asteroids, just to be clear. So I'm going to talk about that for 2 hours right now. So Beth, you better be able to stop me.
Okay, I'm ready. I'm ready. Go.
Now, so this mission, the goal of this mission is to explore this population, to understand where they're coming from. We suspect that, in fact, in this population, the Lagrange point act like vacuum cleaner, basically.
Right.
And since Jupiter moved also along this orbit, and Saturn as well, a lot of asteroids flew and passed nearby this Lagrange point, and some of them got stuck in the Lagrange point. And that's why when we look at them, we see different populations, like 2 or 3 different populations. Mm-hmm. So this mission...
Well, there's multiple Lagrange points. And so what we're talking about are the 3 and 4, which are leading and trailing...
4 and 5.
4 and 5, sorry. 4 and 5. 4 and 5 are leading and trailing Jupiter. And so they've collected a lot of asteroids by their own right.
Yeah. So it's like opening, I used this analogy once when I was talking to a journalist, it's like opening the bag of a vacuum cleaner that is being used in a house. And by analyzing the fragments, you can know if there is a cat living in the house, there is kids, because you're going to find Lego and all of this. So it's exactly what we're going to do with this mission. We're going
Someone likes eating sunflower seeds, right? Okay.
But we're not going to find Lego or cat hair. We're going to find where they're coming from, the surface color, the composition of their surface. It's a cool mission that's going to go super far in the L4, and then first cross the main belt, go to the L4, and then come to the L5. So on its way, it's going to see the asteroid Donald Johnson in 2025. It's going to take a while for us to get the first scientific data of this mission, unfortunately.
Yeah. So what we're excited for this year is the launch.
Yes.
And then in a few years, we'll talk to you about the science.
In 2025, we will talk about Donald Johnson.
Right. And how many asteroids is it going to explore?
6.
6. Okay. Yeah. So this is actually really exciting. So it's going to kind of stay in that area and pass by a bunch of different objects and get as much data as it can.
That's great.
All right. We're going to move even farther out, and now we're going to talk about Beppy Columbo, which is an ESA mission that is heading for Mercury. It has done several flybys of Venus in order to essentially slow itself down to insert into Mercury's orbit later. But it still has one more flyby of Venus to do, and then it's going to do some flybys of Mercury this year before it can actually get settled into its Mercury orbit. How many? What's Beppy Columbo? What is it? What is it doing? What's its goal? What's it supposed to send back to us?
So it's one of the large mission from NASA to explore a planet. In the case, what excites me the most, since we're talking about 2021, is that it's going to fly by Venus. And you know that we learned a lot about Venus this last year. So
That's
I'm
right.
hoping
That's right.
they are going to use those instruments on Beppy Columbo to analyze this area of the atmosphere where we have detected phosphine.
So if I remember rightly, it can't quite use the detectors it has on it to determine if there's phosphine there, but it can look for some other sort of
Aye.
trace or
If you can find
composition.
any other complex molecules, that would be great. Or analyze as well the UV, the mysterious UV absorber, and maybe find finally what is this UV absorber. That
Right.
people suspect it's coming from organic material as well. Venus is full of mysteries, so having a mission like that, full of instruments flying by, even if it's not the primary objectives, I think it will be great. And I'm pretty sure my colleagues at ESA already thought about this and are already organizing the flybys such that they get as much data as possible of Venus in the context of this recent discovery.
That was my understanding, that even when it I think it had a flyby in October, and that was one of the things that they were trying even then. So I'm pretty sure they'll try again when it does its last flyby. So it's exciting that we actually have something that can maybe help with that science right away. Because
And then
normally you have to wait years.
It's gonna fly by the planet Mercury 6 times and finally orbit Mercury in 2025. So again, in
Again,
2025, we'll be talking about the first picture of Mercury taken by Beppy Columbo.
that's going to be exciting. Well, actually, those flybys, it'll probably get some pictures, but it's not going to be as close in as when it finally makes it into that orbit. So it's basically doing this sort of looping motion to kind of slow itself down and work its way in. Because in order to get there, you kind of have to launch really quickly at a very high velocity, and you don't want to shoot by your target. So they've engineers are amazing. I am always amazed by what they put into designing these things to get them to slow down and speed up using what they have, which in this case is other bodies in our solar system.
Yeah.
So that kind of covers the missions that are arriving and launching and doing all of that. But we have one big thing that everybody's kind of excited about this year.
Why is it?
And also
Yeah.
skeptical about. It's that elusive James Webb Space Telescope launch.
Wait a second. When I started astronomy, they were talking about it already.
I know. Hubble is 30 years old. Right? It's been in space for 30 years. It has had to be repaired in space and can no longer be repaired because we don't have anything to do that. So we have been relying and waiting for the James Webb to go up and take Hubble's place. It's a bigger, it's a newer sort of now telescope, but it has been plagued with its problems, hasn't it?
Yes, a lot of problems. So this time, NASA is confident that the spacecraft will be ready to be launched by an Ariane 5 rocket from Kourou Space Center in French Guiana in October 31st, 2021.
So
Halloween
Halloween.
Day.
So if you didn't have anything scaring you, the multiple $billion, a very
10 million.
expensive, yes, $10 billion, spacecraft satellite telescope that we're all hoping brings us lots and lots of data is also launching that day.
So it's going. The reason is such a complex, expensive instrument, and they're so late is because it's a very complex technology that we have not done before. It's basically a origami telescope is going to deploy in space. is made of multiple segments,
Hmm.
6 meter when it's open in diameter. It's very sensitive in the mid-infrared as well in its invisible light. So he has
Right.
a lot of instruments on board. I think it's 6 of them, if I remember properly. This is 100 times more powerful, more sensitive than Hubble Space Telescope.
Right. And we're one of the big things we're hoping on is some insight into exoplanet atmospheres. So that's
That's what you say because you work for the SETI Institute, but most astronomers will tell you that the main priority of this instrument, and that's the reason I'm a bit always kind of bitter when I talk about it, is to take a picture of a first galaxy form in the mid-infrared. That was really the reason they designed the instrument 20 years ago,
okay. I like my reason better.
and even more than 20 years ago. And then since then, we have made so much discoveries and we learned so much. We discovered that there is 300 million exoplanets potentially habitable in our galaxy.
Hmm.
And this telescope does not really have an instrument to observe those. Of course, it
No,
will
it's
contribute to them,
right.
but
It
it
will
will not.
contribute to that, and we're hoping it finds something and that we didn't see before, which is the big thing. So that's I'm still hanging my hopes on that. Um, really quickly because we want to get to the SETI side of this thing, this talk. One more thing may happen this year. COVID has delayed the construction on the Vera Rubin Observatory, which was formerly known as the LSST. However, it seems like from what I have read that they are still on schedule to have the first light of the telescope at the end of this year.
Yeah.
Uh, Major operations won't start until 2022 when they will start their big. They've changed the LSST is now the survey name. I don't have it off the top of my head, but basically it's going to take pictures of the visible sky every few days, like full images of all of the sky that it can see from where it is every few days, which is amazing. So it can track changes on the sky basically over time. And hopefully we'll find, I mean, I have no idea what we're going to find in that. That's just going to be amazing. It's going to be one of those things that I think it's just going to find stuff we didn't expect. What's the goal though? What are they looking for?
So the Vera Rubin Observatory, that's its official name now,
Mm-hmm.
is more than a telescope. It's
Mm-hmm.
basically an instrument that's going to change completely how we do astronomy. Astronomers will not be the same if this telescope basically do reach the sensitivity that they say they will. Um, by mapping the sky continuously and getting a full coverage of the sky in a week, we are going to get a lot of alerts on things happening in the sky, like supernovae,
Mm-hmm.
comets, trans-Neptunian transient events as well. Sorry, like asteroids, NEAs. Um, they estimate they estimate that in the first 3 years, LSST will discover 10 million asteroids. So that's a lot of asteroids. That's way
Wow,
more
I'm sorry, my brain just
we
kind of
know
went.
1 million of them at the moment. That's and since we discovered the first one in 1801, and we know 1 million of them. In 3 years, LSST will discover 10 million of them. So, so basically, astronomers will be always on their phone receiving alerts about coming from the Vera Rubin telescope. That's why I say it's going to change astronomy because suddenly we are going to have a telescope that's going to be capable of sending us things to observe, which are extremely new, extremely just happened in the sky. And I'm sure there will be a lot of instruments that will rely on LSST. In fact, I
Mhm.
know that because I'm already working on one of them for the Gemini telescope. Now, every time we build a new instrument, an adaptive optic system, an infrared camera, whatever, we talk about how we are going to make sure that this instrument can take data quickly. So if Vera Rubin Observatory detect a transient event in the sky, we can quickly go there and quickly
Right.
take a spectrum and know what this transient event is all about. So
Right.
yeah,
That's a part of the new sort of multi-messenger astronomy that a lot of people are using. You know, how many different wavelengths, how many different instruments can you use to analyze an object so that you completely understand it as much as possible with what we have. And so yeah, being able to jump in and say like, okay, Vera Rubin saw it, we're all going to go check it with everything we have, and then we can piece all of that together. We get a much more complete picture of whatever transient event has happened. So that's really good. I'm excited. To finish up, I know people are asking a lot of questions about what's happening in SETI this year. Are there any updates you can give on BLC1, the potential signal from Proxima Centauri?
So there is nothing official yet, but I heard rumors, and I think I can say them because it's been posted on the bottom of the video we have done at the SETI Institute. So you just go to the video to see the source. Someone identified the frequency. It's apparently a very old frequency used by aircraft, all aircraft. So it's
Ah,
possible that's what has been detected, in fact. So
huh.
now the question you have is how come all aircraft from the 50s was flying nearby the park's antenna for 3 hours? And that's something another mystery to solve. So it seems to imply that BLC1 is not a message from Proxima Centauri.
It's not an extraterrestrial source, unfortunately.
So we will see if that's the paper is supposed to come out soon. They say that it will come this year. So
Right.
that's
We have to keep in mind that this story was leaked and the papers have been submitted are not out and are not live anywhere. So we're going with what we've been told from various sources.
yeah.
Okay.
At SETI Institute, I should mention that we have 70 scientists working on a lot of different projects related to some of those missions we mentioned today, but they also have their own things.
Mhm.
And in fact, a lot of scientist colleagues of mine are doing instruments which are not yet envisioned in space mission, but being tested as a potential future instrument for future space mission. I really like one of them that was spun to me by Pablo Sobran. It's
Mhm.
called the Invader.
Oh, right, the Invader mission. I'm
Yeah,
sorry, I completely forgot about that's really cool.
it's
I'm excited because that one's going to axial seamount, which is about 250 miles off the coast, off the Oregon coast, out on the Juan de Fuca Ridge. And I know this because I've actually been there. So I'm pretty excited for this mission. But they're going to go down. Whereas I was up on the surface and just getting to see the pictures from our submarine rover. Uh, they're going to send stuff down and they're going to get even closer look at those hydrothermal vents and see. We're trying to figure out how life started. What actually caused life in the great soup of the ocean to suddenly appear?
yeah. So that's a scientific part, which is great. But this is also a way to test an instrument that could be one day in a future space mission to explore Enceladus or the ocean of Europa. So they're going to test the operation as well of such a submersible, uh, test the technology, make sure that with these technologies they can fully characterize those vents that's been seen at the bottom of the seafloor.
That's exciting work, and I particularly that link back to Europa and Enceladus and our various icy worlds we have here in our solar system. What else is on the front for SETI though? I know we're upgrading the feeds at our ATA, our Allen Telescope Array. Uh,
Yes, so the feed is being upgraded to be more sensitive and to have a broader wave range. So to be able to listen more frequency. The 42's antenna should have by the end of 2021 a new feed. So better capabilities.
that's
Maybe we should
exciting.
remind people that the ATA is the antenna um, developed, made by the SETI Institute, and now operated by the SETI Institute
Right.
to search for techno signatures.
Okay. Any other SETI things you want to touch on before Rebecca makes a stop?
I just would like to say that I'm hoping that 2021 will not be an alien conspiracy year. meaning that I will love that not every time something happens, we claim this is an alien first and be kind of more scientific on this and more relaxed and analyze the data. I mean, the leak of BLC1 went everywhere in the news. It's a leak. It's a data that's being analyzed. We are recently, Oumuamua also, apparently a professor at Harvard University, has written a book about this, saying that
Mhm.
it could be an alien artifact. Um, Nothing proved that so far. So I'm hoping we're not gonna have a year like this again because it's kind of a tiring. It's very tiring and it's not very bringing any positive facts on the table.
No. So I'm going to answer, see if we can answer a few questions here. How long is the trip to Mars? It depends on when you launch, right?
Yeah. So 8 months is basically what people look for
And that window comes up every 2 years.
every 2 years, roughly.
What do you think the most interesting thing is that we're looking for on the moon?
I think right now we are on the phase in the moon where we're trying to make sure that we could live there permanently. So finding resources like water, making sure that we can land material quickly and take things away. And
And
the next step,
surviving the
surviving,
regolith, because that
yeah,
stuff is
dig into
horrible.
the regolith to make bigger bases.
Mm,
I mean, it's building something in zero gravity almost. It's difficult, so
right.
we are learning that, and that's the point here. And then there is those resources that we heard about, like helium-3, that could be used in fission reactor when we have those. Uh,
And figuring out how to make fuel in situ so we can send resources down or send ships further on.
and anything we're doing on the moon will benefit Earth. The technology that we developed on the moon to survive as a human settlement will benefit as well on Earth because we'll be able to do the same on our planet probably.
Right. I'd like to thank Melanie Smith for the donation. Thank you very much. How will different countries claim land areas on the moon? Will private companies have the same rights access as countries? Look up the Artemis Accords. I'm going to leave it at that because it gets into politics and we don't want to go there. So, but look up the Artemis Accords. That's my answer on that one. Asked, someone named My Pup Loves Franck asked about the Bereshit lunar lander, which had an unscheduled rough disassembly.
Yes.
My understanding, so Bereshit did not survive its landing attempt, and I have heard some rumors that Space IL is going to try again.
Yes.
So I believe they are
It's
in
only a
the.
rumor. I thought it was official.
Is it official?
I don't know.
Things
Maybe.
change so quickly, so I'm not sure. But I think they're in the fundraising phase. So I think they are going to try again, and they're just figuring out what they need to do now. Um, let's see. What's going on with Operation Starshot? It's still they're still sorting out everything. I think they're still taking proposals for how to do stuff. So there's no information on that one. We get asked this a lot. What's the situation with the SETI at Home project? We are not responsible for the SETI at Home project. That is a project of UC Berkeley's SETI group. And we have no word on if they're going to bring it back and have heard nothing about a replacement for it. I'm really sorry. I know that disappoints a lot of people. Not something we have control over, unfortunately, but we do appreciate that you all want to help. Let's see. Oh, the Nancy Grace Roman telescope. That's another one that people are
That's
excited about,
mhm.
not going up until the mid 2020s. So
2025. Yeah, but
2025.
that's for instance just to mention because I was mean with the JWST. This telescope is going to be a telescope with an instrument capable of detecting and imaging Earth, super Earth, and Uranus and Neptune like exoplanets. So there is a specific instrument for that to find those planets, to image them, to analyze the light in it. And that's why I'm excited by this space telescope.
That is exciting. All right, I like that one. Will Arecibo be replaced? We don't know.
No, don't know.
That's a lot of talk right now and no definite answers. I know the scientific community, for the most part, would love to have it replaced. There were some scientific discoveries reported on this week that actually involve data from Arecibo that can't be followed up on right now. So it's actually kind of frustrating. But hopefully, I'm hoping. What is the likelihood that some form of extraterrestrial life will be found within 10 years? What do you think, Franck? What's your take on
I
that?
made this prediction 5 years ago already. As 5 years ago, I say that in 10 to 15 years, we will find the proof of life on an exoplanet. So now it's 10 years. So
All right. So sometime in the next 5 to 10 years, Franck
I think
says yes.
my just to elaborate a little bit, because I say that and a lot of other things, but the journalists just kept this piece and published that only. We have now the capability to image exoplanets and soon the
That's
capability
right.
to image Earth-like exoplanets. There is project on 8-meter class telescope to do that, but also on the TMT, the ELT, and the GMT, which are the giant telescope that's going to come in operation in next 7 years, 7-10 years. So those instruments will probably detect an Earth-like exoplanet, and if as we say, we've been claiming that life come very quickly even when the conditions are not perfect and the planet is not perfectly habitable, like has been the case on Earth, we'll be able to detect the presence of this life, this microbiological life, on the atmosphere of those exoplanets.
I I I think that we're going to find evidence of microbial life here in our own solar system
We
before we
hope.
find evidence of extraterrestrial life. But
It's
I
a
am
race.
just as optimistic that it's going to happen in that time frame.
It's a race, and
It's
that's
a race.
it's a friendly race, but it's a race. But I'm betting on the exoplanet. You're betting on the exoplanet. I'm pretty sure if we talk to someone working for the city ATA, we'll tell you that it's gonna be the ATA that will detect the first.
they'll
Uh,
they'll they'll say it's going to be a techno signature. So
exactly.
all right. Well, we have taken up an hour of everybody's time, and we are very appreciative that you have spent that time with us. If you are looking for ways to support the SETI Institute, your donations are always welcome. We are a nonprofit. We are basically funded by people like you who watch us and talk to us and support us. So we're very appreciative. So there's lots of ways you can support. Please sign up for our newsletter. You can keep informed on our science and events that we're having. Next Wednesday is our SETI Talks event. So that is Wednesday evening. The links are in our Facebook page and on our website, SETI.org. So head over there. You can register at Eventbrite, join our Zoom, and ask questions of our panel. We're going to talk about these big telescopes that are being built right now. So we'll get more into things like the TMT and the Giant Magellan and Vera Rubin. So
All right.
exciting. All right. Well, thank you, Franck. It's been fun as always.
Thank you very much, Beth.
All right. Bye, everybody.